One of the areas of assessment I have on my initial intake form is energy, wanting to understand how it is for my patients, like in the morning, at night, throughout the day. What is energy and where does it come from? Welcome to How Wellness Works. Energy comes from the Greek word energia, which means activity or operation, and in general means your ability to be active. And this, believe it or not, has to do with how healthy a very specialized part of our cells are, the mitochondria. Mitochondria are tiny structures known as organelles inside our cells that are involved in cellular respiration. This is a process that results in releasing energy we make from food. They are our cells' powerhouses. Cells that need a lot of energy, like muscle cells, contain thousands of mitochondria. Here's how it works. When the broken down products from the digestion of food find their way into the cell, a series of chemical reactions occur in the cytoplasm. This is the gel-like material within the cell. This allows some of the energy locked up in these broken down food products to be released and incorporated into the universal energy supplier in cells known as adenosine triphosphate, or ATP. Remaining parts from this process then enter the mitochondria, and in a very complex series of biochemical steps, they are finally converted into carbon dioxide and water. The energy locked up in these remaining fragments is then incorporated into more ATP. The ATP molecules produced in this way can then be used by the cell to supply the energy needed to function. The human body really is a fantastically energetic machine. It has been estimated that pound per pound, the human body, when simply sitting comfortably, is converting 10,000 times more energy than the sun in every second. So what is happening to my patients who report low energy? If the body is such an energetic machine, what's going on that contributes to low or poor energy? For that answer, we have to look again at our cell's powerhouse energy maker, the mitochondria, and what's affecting it. During this fascinating process of cellular respiration that occurs in the mitochondria, byproducts are formed, and these are highly reactive molecules called free radicals. Perhaps the best known free radical produced in this way is the superoxide radical O2, or oxygen. Wait, you're thinking, how can oxygen be a free radical? Don't we need it to breathe and such? Yes, but think of this analogy. Have you ever made a nice big bowl of fresh, bright green guacamole? What happens when it sits out in the oxygen? It turns brown and breaks down, right? So what do culinary folks do to prevent this? They use lemon or lime juice to keep it fresh, and that juice contains ascorbic acid from vitamin C, which is a potent antioxidant. So yes, oxygen in this case is a free radical. Next, oxygen in the body splits into single atoms with unpaired electrons. Electrons actually like to be in pairs, so these unpaired electrons scavenge the body to seek out other electrons so they can pair up. This process causes damage to the cells and our DNA. And although free radicals are damaging, they do have an important signaling role. Scientists now believe that mitochondria operate a sensitive feedback mechanism in which some of these free radicals act as signals to the cell, causing it to calibrate and adjust cellular respiration. So to remove them completely is not good for the cell. If too many free radicals are released in the mitochondria, the damage can be severe, resulting ultimately in the death of the cell. To protect against free radical damage, mitochondria do produce their own antioxidant enzymes. One of them is known as superoxidase dismutase, or SOD. But oftentimes this is not enough. So to maintain healthy mitochondria, there are several things you can control. One method of preventing oxidative stress is to ensure that you're obtaining enough antioxidants in your diet. Eating 5 to 9 servings per day of a variety of fruits and vegetables is the best way to provide your body what it needs to produce antioxidants. Healthy fats like omega-3s from clean fish and monounsaturated and polyunsaturated fats from avocados are also important fuel for healthy mitochondria because they are a big part of the cellular wall. What you don't eat counts too. Avoiding highly processed, nutritionally valueless food and too much sugar or alcohol is important. Also, avoid smoking and known environmental external influences like pesticides, car exhaust, and pollution, as this can create more free radical activity and cause oxidative stress. Regular exercise, believe it or not, helps to not only protect but increase the number of mitochondria. There is also supplementation. Proven antioxidants like alpha-lipoic acid and coenzyme Q10 support energy production. They are both needed in the complex processes that help protect the mitochondria. It is estimated approximately 75% of Americans don't meet their daily need for magnesium, and magnesium is a cofactor in the many processes essential for the production of energy. Vitamin C, vitamin E, and B vitamins, iron, and selenium are also required nutrients that might very well need to be supplemented to make this process optimal. And remember, this process of making energy in our cells requires a myriad of reactions. So if energy is an issue for you, consider seeing a qualified practitioner who might do a functional medicine test to uncover a potential disruptive source. And if you're struggling with low or poor energy throughout the day, by all means, like this video and as well comment below so we can keep the conversation going.